Okay, so let's look over those volume day 2 homework problems for those of you that might need a little bit of extra help. This should clear anything up, okay? So our first object there, that is going to be a pyramid. And we know that the volume of a pyramid is equal to 1/3 the area of the base times the height. Well, in this case, the base is a square with each side being 16 meters. So the volume is going to be 1/3 the area of the base, which would be 16 squared, times the height, which is going to be 24 meters. Okay, when we simplify all of that, your volume here is going to be 2,048 cubic meters. Okay, all right, now if we look at the second one, it's also a pyramid. And if you remember Cavalieri's principle, it basically states that whether it's a straight pyramid or oblique, the formula is going to be the same. It's going to be the area of the base times the actual height, not the slant height, the actual height. Okay, so again, we have a square base, and we know what the actual height is. It's 5 meters. So the volume is going to be 1/3 7 squared times the height, which is 5. And I'm just going to round this to the nearest tenths. Once we simplify all this, the volume is going to be 81.7 cubic meters. Okay? Our third example requires a little bit more work because here they give us the slant height, but not the actual height. And I know that the volume is equal to 1/3 the area of the base times the actual height, not the slant height. Okay? So we're just going to assume that this is a square base and each side is 10 meters. Okay? Well, half of that would be 5. And if I drew this perpendicular line up here, this would be my actual height over here. So this is actually a right triangle here. I've got h squared plus 5 squared equals 12 squared. So that's how I can find the height of this pyramid. So I'm going to have to use Pythagorean theorem. H squared plus 5 squared equals 12 squared. All right, so h squared plus 25 equals 144. We subtract 25 from both sides. H squared equals 119. And if I take the square root, my height is going to be approximately 10.9 meters. Okay, guys? So that's what I'm going to plug into the formula for height. So I know the area of the base is going to be 10 squared. So the volume equals 1/3 10 squared times the height, which is 10.9. So the volume, if I simplify all this, is going to be approximately 3,633.3 cubic meters. Okay? There you go. All right, the bottom example down there, that is a cone. And remember, it's an oblique cone, but it has the same formula as a straight cone. So if the diameter is 4, then that means the radius is 2. And remember, the volume of a cone is equal to the area of the base times the height. Well, the base of a cone is a circle, and I know that the area of a circle is pi r squared, and then we're going to multiply that by the height. Okay? And remember, you have to do, it's actually 1/3 the base times the height, the area of the base times the height. Sorry about that. So it's 1/3 pi r squared times 4. Okay? So whenever we simplify all this, it's 1/3 pi 4 times 4. Okay? And so that simplifies to about 16.8 cubic feet. It's said around the nearest cubic feet, so that's 17 cubic feet. Whoops, there you go, 17 cubic feet. All right, let's look at the next example that was on your homework. Okay, we've got another cone, and here we don't know what the radius is. We do know that the volume of a cone is equal to 1/3 the area of the base times the height. Okay, so what we have here is we don't know the radius. So I know the volume equals 1/3 pi r squared times the height. What I do know is that this is a Pythagorean triple. You got 15, 15, 17, and a missing part over here, which happens to be 8. 8 squared plus 15 squared equals 17 squared. So if you know your Pythagorean triples, you would know that your radius is 8 units long, okay? So the volume here is going to be 1/3 pi times 8 squared times 15, okay? And when we multiply all that on out, the volume is going to be 1,000 5.3 cubic meters. Okay, there you go. Next example, again, we've got a pyramid, and it's 1/3 the area of the base times the height. This time, a triangle forms the base of your pyramid, okay? And I know that the area of a triangle is 1/2 the base times the height. So the area of this triangle is going to be 1/2, let's say 8 times 6, okay? 1/2 of 8 times 6, which is going to be 24. So the volume of that pyramid is going to be 1/3 24 times 12, okay? So when we simplify all that on out, we're going to end up with 96 cubic feet. There you go. All right. Now our next problem is a hemisphere with part of it cut out, okay? We've got 45 out of 360 degrees cut out of the hemisphere, okay? That simplifies to 1/8. So 1/8 of the hemisphere is cut out. So what we could do is we could find the the volume of the hemisphere and multiply that by 7/8, because that's what's left, okay, when you take out that 1/8. All right? So if you remember, so the volume of a sphere is 4/3 pi r cubed. So the volume of a hemisphere, a hemisphere is going to be 1/2 of that, 1/2 of 4/3 pi r cubed. All right? When you simplify that, that makes it 2/3 pi r cubed. So that's how you find the volume of a hemisphere. It's 2/3 pi r cubed. All right? So I know the radius here is 3. So the volume of this hemisphere, I'm just going to do it up here, is 2/3 pi times 3 cubed. Okay? So the volume of that hemisphere is 2/3 pi 3 cubed. All right? So that's going to end up being, when we multiply all that on out, 56.5 cubic units. Okay? Because we are finding the volume of 7/8 of that, because 1/8 of it has been cut out, we're going to say 7/8 of 56.5 cubic units, and that's going to make it 49.5 cubic units. Okay, there you go, guys. All right, the last one here, before we get to those composites, the radius of an official NBA basketball is about 4.7 inches. Estimate the volume of a basketball to the nearest hundredths. So here you've got a straightforward sphere. It's going to be 4/3 pi r cubed. So the volume is going to be 4/3 pi times 4.7 cubed. And when you simplify all of that on out, you're going to get 434.89 cubic inches. There you go.